All right, so this was 6.5 and 6.5. We learned how to plot the complex numbers, get the absolute value of them, and then write the complex number in trig form. Those were like the three major topics in that section. So for plotting, I would just look at what's given to me, that -3, positive 5i. The -3 is your A, the 5 is the B. So you would literally just go left 3 and then up 1, 2, 3, 4, 5. And my point, it's a point, not array, would be in that top left quadrant or the second quadrant. To find its absolute value, we do the square root of A squared plus B squared. So I'd get the square root of -3 squared plus 5 squared, square root of 9 plus 25, which is square root 34. That only breaks down to 2 and 17, which would be prime, so it's going to stay as square root 34. So on your test, you're going to have your calculator the whole time. Some of the answers are going to be left exact, and some of them will tell you to round. Like think law of sines and cosines, that kind of stuff was the ones we had to use the calculator for. Those are the ones you'll round. Something like this you'll keep exact. So you'll need to keep it in radical form. If you can simplify it, you do, but if not, you keep it just the way that it is. For 2, -5i, your A is now 0 and your B is -5. So I don't move left or right at all, and I just move down 5 spots. That's where the coordinate point would be. And then the square root of 0 squared plus -5 squared would be the square root of 25, which goes back to 5, and that's the magnitude there, or the absolute value. Questions on that one? All right, and then 3 and 4, we'll write the number in the complex number in trig form. So remember that z equals r times the cosine of theta plus I times the sine of theta. To get r, it's the square root of a squared plus b squared, and to get theta, we do tan of theta equals b over a, and then locate it on our unit circle. So if I have that 0, -5, I already know r because I got it already from number 2 would be 5. And then a was 0 and b is -5. So the tan of theta is equal to -5 over 0. That means it's undefined. I'm just going to give you a unit circle, like a small unit circle on your test. And so you can add in your tangents when you get it on Thursday instead of giving it Wednesday and then having to give it back. So you're just going to get a plain unit circle. It will be filled in like this one. Like I'm basically just going to give you a small version of this, okay? So when you get your unit circle, you can either add this, right? So 0 over 1, this would be 0. This would be root 3 over 3. This would be 1. This would be root 3. And this is undefined. Or you could write like on the top if you wanted to. Over 2s are undefined. Over 3s are root 3. Over 4s are 1s. Over 6s are root 3. Over 3. And then the 0 and the pi are 0. Or you could go all the way around your unit circle. I just don't want you to waste your time doing too much when you may not need, you're only going to need like 2 of those points. So then tangent undefined is going to happen at the top at pi over 2 and at the bottom at 3 pi over 2. 0, -5 would be down here. We already plotted it. So I know to pick theta as 3 pi over 2. And then I plug it in. So z would equal 5 cosine of 3 pi over 2 plus I sine of 3 pi over 2.
Wait a minute, how do you know like which one to pick?
Where it's graphed, where 0, -5i would be.
Oh.
Yeah. So then the next question that I covered up, hang on. 1 plus I would be A being 1, B also being 1. I would have gone right 1 and up 1. That's where my coordinate point is. And then R equals the square root of 1 squared plus 1 squared, square root of 1 plus 1, which is square root 2. And then tan of theta would be B over A, 1 over 1, which means it's 1. On my unit circle, tangent is 1, 2 spots, pi over 4 and 5 pi over 4. I know to pick the pi over 4 because 1, 1 would be in the first quadrant. So theta is pi over 4. And then when I write it in that trig form, I get root 2 times the cosine of pi over 4 plus I times the sine of pi over 4. And again, you'll leave it like that. So your radicals need to be simplified, but everything else stays there. Don't forget the I on the sign. That's what makes it complex. You need it. All right, last question on the homework. This one said, represent the complex number graphically. So the first thing you have to do is figure out what that complex number would be. Okay, so if I take and distribute the 3 and I get 3 cosine 45 degrees plus 3 I sine 45 degrees. 45 degrees, my coordinate point there is root 2 over 2. So the cosine there is root 2 over 2, and the sine there is root 2 over 2. I would just rewrite this as 3 root 2 over 2 plus 3 root 2 over 2i. That would be the complex form. So the A is 3 root 2, and so is the B. That's a positive. So if you had to actually graph it, you could approximate root 2 to be like 1.4. And then you could simplify it and multiply it times 3. So 2 would go into 1.4.7 times. And this would be a 2.1 plus 2.1i. So I'd go to the right about 2, and I'd go up about 2. And that coordinate point is this one. And then to put the standard form of it, you just rewrite it the way that we had it. So this is like, I would prefer it to be in simplified form like this. WebAssign will take it, separate it out like that, but you want to just distribute it in and get it into standard form. All right, so your review note, again, is on the assignment. I think when it comes out, like if you open it in Notability, the background is white. Some of the ink is yellow, so if you want to change it to black, you can, okay? But we're going to go through this review note. All right, so on your test, you're going to have a mix of law of sines, law of cosines. It's not quite as much as your quiz. It's only like one of each one. And it's like one where it's just the generic triangle, and the other one would be applied through a word problem. So you really only have one of each of them. It just depends on what you're going to get. You might get the drawing, the actual information about a triangle for law of sines, and then the word problem, law of cosines, or vice versa. Okay, so you just got to be prepared for all the different types. Remember, if you're doing law of sines and you are given angle, angle, side, you would find the third angle, and then you set up your proportions, you cross multiply and divide. The tricky one was when you're given side, side angle. So this is your ambiguous case. So if you want to draw it out, feel free. I would draw it out. I would say this is A, this is B, this is C. I'm given angle B, which is 30 degrees, side B, which is 27, and side C, which is 32. And from there, you should be able to tell that you're given two sides in the non-included angle, which is the ambiguous case type. So the first thing I'm going to do is find the missing angle because I have both B's. I will always use that ratio. I will use 27 over the sine of 30 degrees equals side C, which is 32, over the sine of angle C. And then I'm going to cross multiply and divide. So I get 32 sine 30 divided by 27, and I get sine of C equals 0.5925, so on and so forth. So I'm going to inverse sine that. And I get angle C, and I'm going to call it C1, 36.34 degrees. So that's my assumed first triangle, 36.34 degrees. And then second triangle, I would start by doing 180 minus that. So 180 minus 36.34, I think we've done this example before. Well, just that angle at least, is 143.66. I can check for my third triangle, my second triangle already by figuring out if this third angle is positive or negative. So I'm going to check to see if that last angle is positive or negative. I'm going to do 180 minus the 30 degrees from my original B minus the C2, which is 143.66. 180 minus 30 minus 143.66. And it's tiny, but it is positive, 6.34, which means I have a second triangle. I'm going to go back and finish the first one and then make sure I come back in here to finish this one. So the last angle on the first triangle is my A1. I'm going to do A1 equals 180 minus the 30 degrees I was given at the beginning minus the 36.34 I found from my first angle. And I get angle A1 is 113.66. And then the last thing I need to find from my first triangle is side A1. So I use the original B's that were given. 27 over the sine of 30 would equal A1 over the sine of 113.66. I'm going to cross multiply 27 times the sine of 113.66 divided by the sine of 30. And I get A1 equals 49.46. Last thing I have to find from my second triangle is side A1. Again, using the B's, 27 over the sine of 30 would equal A2 over the sine of angle A2, which was 6.34. Cross multiply. And side A2 is 5.96. Remember, the other scenarios are no triangle. So from that, the very first ratio, you'd end up getting something that says sine of theta is bigger than 1, and that can't exist. So you would rule out that first triangle, and there'd be no triangle. Or you get one triangle, you go to find the last angle on the second triangle, which was here, and that would have been negative, like A2 in this case, would have been negative, and then you know there's only one triangle. Questions on law of sine? All right, in 6.1 was our first area formula, and that is the area when you're given side angle side. So if this is your area equals 1/2 AB times the sine of C, or 1/2 AC sine B, or 1/2 BC sine A, whatever the three things that you're given. So I gave you angle A is 52 degrees, side B is 7, and side C is 8. And you literally just plug it in. So 1/2 times 7 times 8 times the sine of 52. If people got this question wrong on their quiz, it's because they put cosine here. Okay, area does not involve cosine. It's sine. So this would be sine of 52. Area here is 22.06. And it didn't give me a unit. It would just be unit squared if there was one. So we need law of sines. We need area from the sine section. Then you go law of cosines. Law of cosines was all these formulas. So if I'm looking for a side, it's that side squared plus the sum of the other two minus 2 times their product times the cosine of the same letter that matches. So this is all for side, side, side. And this one, no, sorry, that would be for side angle side. And then the bottom ones are for side, side, side. So when it's side angle side, if you're given an obtuse angle, then you can switch to law of sines. But remember I said it's safer just to stick to law of cosines. If you're given side, 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 if you find the largest one first, then you can switch. But again, I would recommend just sticking to law of cosines. It's safer. You don't have to worry about the order. You don't have to worry about what's given. So for example, if you're given 3 sides, 12, 17, and 20, I can find C. I tend to start with the large one just to avoid the mistakes, but you don't have to. Cosine of C would equal 12 squared plus 17 squared minus 20 squared over 2 times 12 times 17. And then I cosine -1 that whole thing, and this is when the parentheses were super important. So second cosine, open the parentheses again, 12 squared plus 17 squared minus 20 squared. Close the parentheses, divided by open, 2 times 12 times 17. And I'd get angle C in this case is 85.36 degrees. Then I'm going to repeat that process for the other angle, and I can pick either one. So I'm going to say cosine of A equals, and this would be b squared plus c squared minus a squared over 2bc. So I'm going to cosine -1, 17 squared, plus 20 squared, minus 12 squared over 2 times 17 times 20. Second, cosine, open the parentheses, 17 squared, plus 20 squared, minus 12 squared, close the parentheses, open, divided by, open the parentheses again, 2 times 17 times 20. And I get angle A is 36.73 degrees. So then when I go to find angle B, the last one, I can just do 180 minus these two. So 180 minus 85.36 minus 36.73. 57.91 degrees. You can also check it using law of cosines. Like if I wanted to use the inverse of cosines, I should have gotten, it may not be exactly the same because we've rounded, but it should be pretty close to that 57.91. Questions on that one? So again, law of cosines are side angle, side, 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 side. Everything else is law of sines. And you can either see this by way of what we just did or written into a word problem. All right, Heron's formula was the second area formula, and this is when you're given side, side, side. So if I know all three side lengths, I use Heron's formula. S is A plus B plus C over 2. We do not round S. I think probably 2 people did it the whole day on the quiz day, but don't round it. And then the area is equal to the square root of S times S minus A times S minus B times S minus C. So if I wanted to find the last one, I'd add the 3 sides, divide by 2, that's my S, and then remember, let your calculator do the work. Just be careful with your parentheses. And again, your word problem is either going to be, you're going to get a word problem here. That's either law of sines or law of cosines, whichever one you kind of don't get at the beginning. So you're just going to have to do one of each one. Questions so far? Okay, then came all the vector stuff. So we started with component form and magnitude. So you can get given an initial point and a terminal point, and it will say find the component form and the magnitude. So for component form, this is the x2 minus the x1, comma, y2 minus y1. The x1 and y1 are determined by initial terminal, right? Initials the 1s, terminals the 2s. So for component form of this magnitude, it goes in those brackets. It would be -7 minus 2, and then 6 minus a -5, and that becomes -9, 11. The magnitude you can either find by doing the square root of a squared plus b squared, or the distance formula from my initial and terminal, x2 minus x1 squared plus y2 minus y1 squared. If you already have the component form, I would recommend the a squared plus b squared. If you don't, then it really doesn't matter. You're either going to have to find the component form and then do a squared plus b squared, or you could just use the distance formula from your points in the beginning. It's completely up to you.
So for magnitude, we can use the first or the second equation?
Correct. If you have initial and terminal. If you don't have initial and terminal and you only have the component form, then you're only going to be able to use the a squared plus b squared to find the magnitude. So this would be the square root of -9 squared plus 11 squared, square root of 81 plus 121, and that's square root of 202. This would be 2 and 101, which doesn't go any further. So I would keep it exactly like it is. This is one of those scenarios that you have to be careful. Obviously, you're going to have a calculator in front of you, and it will be tempting to just type that in. But if you give me a rounded decimal answer on these, they will be marked wrong. The directions will say keep it exact, and that's what it means. Yeah.
So, will there be a question where we don't have to find the component form and just give us magnitude and use distance formula?
That you have to? No. Yeah, no, you'll have that choice.
You don't have to use the distance formula?
You don't have to. No, because you can always find component form first. Yeah. Okay, then you got stuff like find the following and state whether the results a vector or a scalar. And we had it adding, subtracting, multiplying by a scalar, that kind of questions. So for this first one, for A, let's call it U plus V, we would add the two first terms. So the two changes in X, this would be 2 plus 1. And then add the two changes in Y is negative 3 plus 4. And I end up with 3, 1. Is that a vector or a scalar? That's a vector. Good. Four V minus U means I start with 4. I multiply it in on V. So 4 times 1 comma 4. And then I'd subtract from it U to negative 3. I distribute here, so I'd end up with 4/16 minus 2, negative 3. 4 minus 2 is 2. 16 minus a negative 3 becomes plus 3, and that's 19. Vector or scalar? Good. Dot products end in scalar. All right, then we had stuff like find the component form of a vector with a magnitude of 7 that forms a 30-degree angle with the axis. So if you're given the angle, which is the case here, and the magnitude, we find the component form by doing the magnitude times the cosine of theta, either comma or plus the magnitude times the sine of theta. This would have been in brackets, or you would have done magnitude cosine of theta plus I magnitude times the sine of theta. So this, or not I, sorry, this would be IJ. The I would be here, I plus magnitude times the sine of theta, J. So pay attention if it says put it in IJ format. Remember the X, the change in X gets the I, the change in Y gets the J. If it's in component form like the first one, then you don't have the IJ, you separate it with a comma. So if I'm given the angle and the magnitude, this would be 7 times the cosine of 30 degrees, comma 7 times the sine of 30 degrees. This is when I would also need my unit circle, but I need the sines and cosines. So if I went to my unit circle, which again I'll give you, and I find 30 degrees, the coordinate point there is root 3 over 2 and 1/2. So the cosine there is root 3 over 2, and the sine there is 1/2. So I would get 7 root 3 over 2, comma 7 over 2. That would be component form, because that's what this is asking for. If it said put it in IJ format, I would get 7 root 3 over 2I plus 7 over 2J. So just pay attention to directions. If it says component form, I put it with the brackets and the comma. If it says IJ, I put it with the I, the J. If it doesn't say it, it usually is already giving you some sort of form of vector. You put it back in whatever the format of the vector was. Like this one doesn't, but it tells you what to do. Yep.
You completely replace, like you wouldn't completely solve.
You would. Yeah, this time you do. This is not component. This is not, don't think of this as the complex number at the end. This is not trig form. This, they'll give you the angle and they'll give you the magnitude. Okay. Then we had questions that said find the component form of a unit vector. Okay, what did the word unit mean? The same direction is the component form of the magnitude of the vector that's given over the magnitude of the vector that's given. Okay, you only have one vector. So if I give you that the vector is V and it's 1, 4, I put 1, 4 in the numerator, and then I find the magnitude of this, square root of 1 squared plus 4 squared, square root of 1 plus 16, square root 17. That goes in the denominator, and then we have to split this. So it's 1 over root 17, comma 4 over root 17. And then we rationalize. So we multiply both the numerator and the denominator by square root 17. And I get root 17 over 17, comma 4 root 17 over 17. Again, it said component form, so I know to leave it just like that. If it had said put it in ij, then I give it the I and the j, put the plus between it. And this is unit vector, so I'm done where it is. If I wanted to, if I had extra time I could check, I would do the square root of a squared plus b squared on that, and my answer should be 1. Now the directions change here. It says find the component form of a vector in the same direction. So I know I start the same way, but with a magnitude of 5. So now I'm going to do the component form in the top over the magnitude of whatever one is given to me. And then at the end, I multiply it times 5. So I'm going to distribute that 5 into both of those. So I first find the unit vector, and then I multiply it times 5 at the end. It's the same vector, so I already did the work. The unit vector here would be root 17 over 7 and 4 root 17 over 17. Now I have to multiply in 5 to both of those. So it becomes 5 root 17 over 17 and 20 root 17 over 17. That would be a unit vector in this, or sorry, that would be a vector in the same direction with a magnitude of 5. Mm-hmm. All right, then we have the graphing of our vectors. So this one says, given the graph below, find u plus 4v. So what do I do with 4v? I get it 4 times as long as v, right? So v is the one at the top. If this is 1, this would be about 2, this would be about 3, this would be about 4. So that looks like it's 4v. If I want to add them, how do I do it? Good, that little parallelogram. So I'm going to draw a line out here. That's a parallel to the v side. And then I'm going to draw a line out from here. That's parallel to the u side. Where they meet is the end point of the sum. If it had said like negative u plus 4v, what does the negative do? Good, changes the direction. So this would be negative u, and then I would have had my points meet here. Okay, so negative changes the direction on it. Obviously, a scalar on the front changes the length, and then you're going to draw that little parallelogram. It doesn't have to be perfect, but it should be around about where it should be. Questions on graphs? Yeah.
Would this be one that it has the number on it?
No.
Or is it just a drawing?
It's just a drawing. Yep. There will be another word problem from the component. This would be like the part 2 part of your notes, where you're looking for the horizontal and the vertical component. So like if you look back at the notes, it was like example 7 from 6-3 part 2. It was it was like physical education, and it was something thrown, like a ball was thrown, and you needed to know the horizontal component and the vertical component. And then you had a homework question in the part 2 that was number 8, which was similar, like a gun was shot in the muzzle, whatever that is. So to find the vertical component, we do the magnitude times sine of theta, because it will give you the angle and it will give you the velocity. Those are the same things. Magnitude, velocity are the same thing. And to get the horizontal component, it would be the velocity or speed or magnitude times the cosine of theta. These won't be unit circle based, so these would be like rounded to a specific digit. There is not one of those on the PDF review, so if you want to go back and practice an extra version, I would say the homework 6-3 part 2, practice another version of question 8. All right, 6-4 was your dot product and your angle between. So a lot of just application of that dot product. I didn't do a lot of stuff from this because there was a lot of like little stuff in between. Just make sure you know how to find the dot product, how to apply scalar to it, kind of like what's there. Obviously, the angle between is a formula you need to know, and then the orthogonal parallel vectors all came from 6-4. So dot product is where we multiply and then add them together. So the dot product of u and v would be 2 times 1 plus negative 3 times 4, 2 minus 12, which is negative 10. If it says something like 2 times u dot v, I could do this in a couple different ways. I could do u dot v first and then multiply it times 2, or I could do 2 times one of those. 2 times u, that times v. You cannot distribute here. Remember, if it's not a plus inside the parentheses, we don't distribute. So for this one, I could find u dot v first, which we just did, which is negative 10, and then I'd get 2 times negative 10, which is negative 20. Because it's not a plus. There's not a plus here, right? Like plus is when we, addition or subtraction is when we distribute. If you distribute, it's only to the u. You could do that. Or only to the v, not to both. The angle between is the cosine of theta equals u dot v over the magnitude of u times the magnitude of v. So the dot product we already have is negative 10. So this would be the cosine of theta equals negative 10 over the magnitude of u is the square root of 2 squared plus negative 3 squared, square root of 4 plus 9 square root 13. The magnitude of v is the square root of 1 squared plus 4 squared, square root 1 plus 16, square root 17. And then we cosine negative 1, that whole thing in the calculator. This time you do negative 10 divided by, you don't have to worry about grouping the numerator, but you do have to keep both 13 and 17 underneath your square root in your denominator. And remember, the negative has to be the button that says negative, not the minus sign. (132.27). And if I graph those two vectors, I should see a big obtuse angle between them. So you can always kind of get an idea if you're on the right track. You're welcome. All right, then orthogonal and parallel. Remember, we're going to find the slopes here. So if my component form is the change in x, comma, the change in y, then I would do the change in y, which is the second term, over the change in x, which is the first term. For orthogonal, my slopes are opposites reciprocals. Or dot product equals 0. For parallel, they have the same slope. You can't use your dot product to figure that one out, though. So I would just say set up your slopes and look at them. It's either going to be parallel, orthogonal, or neither. And then we end up where we started the day at the warm-up. This is 6-5. So plot the complex number, find its absolute value. Absolute value is the square root of a squared plus b squared. The a is what's in front of, or the one without the I. The b is the one with the I. So if I was to plot this, it would be 1, 2, 3, 4, 1, 2, 3, 4, 5 here. Absolute value would be 4 squared plus negative 5 squared, 16 plus 25, square root 41. And then finding the trig form, this is the z equals r times the cosine of theta plus I times the sine of theta. R is the magnitude or the distance or the absolute value. And tan of theta equals b over a. These will be unit circle based, so these will be kept exact. So square root of 3 root 3 squared plus 3 squared. This is 9 times 3, so 27 plus 9, square root 36, which is 6. That's my r. Then the tan of theta would be 3 over 3 root 3. These cancel. I get 1 over root 3, which gets rationalized to root 3 over 3. So then I would go to my unit circle. The root 3's over 3's are the over 6's. And these are both positive, so it would have been the over 6 in the first quadrant, which is pi over 6. So z equals 6 times cosine pi over 6 plus I times sine pi over 6. If you had extra time, you could check that by actually figuring out what's happening at pi over 6, what's the cosine, what's the sine, and then multiplying it times 6. And you should get back to your question. Yeah.
Do you know which budget it's in from A and B?
From the original location. Yep. So if you wanted to graph it from the beginning, like give yourself a little small graph, you totally could. Then narrow it down to that quadrant from the beginning. You could do it.
Bearing's gonna be on the test.
Say again?
Our bearing's gonna be.
They could be in a word problem.
Okay.
Yep. So your homework tonight is to do as much of that PDF as you can so that you come in tomorrow knowing what you know and you don't know and what you need extra help with.